Love you too.
You're unlimited guess.
All right.
That's when you just push keep going until you like write down one answer and wait till it comes up again.
Yeah, that's what they do. That's what people in AP Calc do. Yeah.
That's what I did in algebra 2 last year.
Or just hit start. Yeah.
Okay. The fundamental theorem of calculus meets definite integrals. Okay. The fundamental theorem of calculus allows us to find area under the curve. Okay. Definite integrals help us find area under the curve. So what we do is if this has a first derivative of this, and its first derivative is this, okay, then when we integrate a first derivative, we get what is there. So basically, when we're doing an integral of a function which has a derivative, when we know what the derivative is, we're taking 3x squared minus 6 and putting in 0 and -1 into the function and subtracting those two functions. So it's 3 times 0 squared minus 6 minus 3 times -1 squared minus 6. Okay, because we're finding the difference between the two and then subtracting them, and that would be the area under the curve. So what's 0 squared? 0 times 3 is 0, gives us -6. -1 squared is 1 times 3 is minus 6 is -6 minus -3 is plus a positive, and we get -3. That's our answer. Okay. The cosine of 3x. So it's the cosine of 3 pi minus the cosine of 0 pi, because it's put in pi for the x, and subtract them. What's the cosine at 3 pi? Well, if you think of your unit circle, 1 pi, 2 pi, 3 pi. What's cosine there? -1. What's the cosine at 0? 1. So what's -1 minus 1? -2. Okay? So that's how to find areas under the curve of a derivative using integrals, definite integrals with numbers at the top and bottom. Now, definite integrals are related to antiderivatives. What's an antiderivative? Well, it's the opposite of the derivative. Okay? So, if you take the antiderivative and take the derivative of it, you get the function. So going the other way, the function, to find its antiderivative, So what I do for this section is I take the derivatives of the antiderivatives to see which one matches. What's the derivative of y cubed plus 16y squared?
3y squared plus 32y.
So this one matches with this one. What's the derivative of this one? 2y plus 2. This one matches this one. The derivative of this one is? So that one matches that one. So it's just a matching. You're just putting things in order. So then, now we have an integral. The integral is the antiderivative. So this is the antiderivative. So if we take the derivative of the first of what's over here, we get what's over here. Okay? So where does this one go? 4x plus 5. Where does this one go? bottom, and this one goes here. Okay? And it's just shifting around things. And that's all we're doing before lunch. Is just this stuff here and this stuff here. And after lunch, we are doing a quiz. And then we'll get more into it tomorrow. But this is just basics today. So